Okay, in this video we'll be talking about trig identities and how to use them and proving trig identities. Alright, so what is an identity? An identity is where two functions, f of x and g of x, they are equal on both sides. So what we're going to be doing is taking these trig identities and balancing the equation where they are equal on both sides. Now, there was a paper that you had that you should print out or have copied these in your notebook. These are all the different types of identities. We have something called reciprocal identities, which we already know that cosecant, the reciprocal is 1 over sine. Secant, the reciprocal is 1 over cosine. Cotangent, the reciprocal is 1 over tangent. We also have quotient identities where it says their tangent is sine divided by cosine. That's the y divided by the x on the unit circle. And then cotangent is flipped around, cosine over sine. And then the last one are all these Pythagorean identities. So this box here is just these things moved around and solved for sine squared and cosine squared. And the same thing for this. This is where they are moved around, solved one of these for tangent squared theta, besides secant squared theta, and the same thing for this last box down here. Right, now how are we going to use these things? So let's take a look. One example here says, rewrite everything in terms of sine and cosine only. So you're going to that identity paper, and you're saying, okay, what can I replace tangent theta with? So let's go back. I'm going to erase these things. Where is tangent theta? Well, I see tangent theta right here. It says replace it with cosine and sine only, and that's perfect. So let's go ahead and do that. That's going to be sine divided by cosine times. What can I replace cosecant with? Well, let's take a look. Cosecant, oh, this is good, is equal to 1 over sine. I'm going to multiply these things. What happens is just like numbers, I could cancel what with what? Sine theta and sine theta, because in the numerator and denominator, those could be canceled. So when I multiply across, I get 1 on the top and cosine theta on the bottom. Here is my answer. So this is not proving an identity yet. It's just having you rewrite things in terms of sine and cosine. Now let's get into establishing and proving an identity. Here are the steps. My suggestion is to replace everything with sine and cosine first. So you're going to your identity paper and saying, all right, what can I replace that thing with that has sine and cosine in it? You are not allowed to move things from one side to the other. So you always have to manipulate the left-hand side and the right-hand side separate. You can add, subtract, multiply, divide to simplify. So that's what I was talking about, working on one side and doing that, or the other side. Maybe you need to factor. And then the last thing, your objective is that you want both sides equal at the very bottom. All right, so here is the first identity we're going to prove. So let's prove this identity right here. Cosecant theta times cosine theta, they're saying it should equal cotangent. So let's replace everything with sine and cosine. So looking at your paper, what can I replace cosecant with that has sine in it? Well, that's 1 over sine theta. Since the second thing already is cosine, I don't need to replace it with anything. But if you notice, I'm just going to put it over 1 because the first one is a fraction. So it just helps me out when I have to multiply. Equals, what can I replace cotangent with? That's that cosine over sine. So what does the left multiply out? Multiply the top. 1 times cosine is cosine, and 1 times sine is sine. That's on the left-hand side. And we bring this down, the thing that we have on the right, and take a look. Real simple. They are equal. All right, let's take a look at another example. Prove this that it's an identity. So we have cosine squared theta, and in parentheses is 1 plus tangent squared theta equals 1. Now, cosine squared theta is already in terms of cosine. What can I replace 1 plus tangent squared theta with? So I'm going to go back to here. Does anyone see 1 plus tangent squared theta? I see something right here. 1 plus tangent squared theta is secant squared theta. And then what can I replace secant squared theta with? Well, we know secant theta is 1 over cosine, but since it's squared, right, what do you think is going to happen to the bottom? It's also going to be squared. So these two things are the same thing, except it has a little squared there. So let's go back. All right, so I'm not going to touch that. We know that 1 plus tangent squared is that secant squared, equaling 1. All right, we just talked about that I could take that secant theta 1 over cosine and make it 1 over cosine squared because of the squared there. I'm going to put this over 1. Hopefully now you see something. What's going to cancel? The cosine squareds. And all I'm left with is 1s. So I have 1 on the left, 1 on the right. We prove the identity. All right, let's look at this one here. Cosecant theta minus 1, cosecant squared plus 1 equals cotangent squared theta. All right, so the identity that we have over here, let's see, let's erase this here. Let's erase all this. What was it again? Cosecant minus 1. Okay, so you might say to yourself, ooh, this looks like pretty good here, this one right here. But nope, we have it as cosecant theta minus 1. And this one, you're not allowed to drop this off and make it like that, like we did for the reciprocal identity. So that's not possible. We could change that ending one to this, but let's take a look and maybe multiply it out. So I'm going to multiply this out here. So doing FOIL. So cosecant times cosecant is cosecant squared theta. Cosecant times 1 is cosecant. Then the middle, minus cosecant. And then at the end, negative 1 times 1 is negative 1, equaling cotangent squared theta. So these things in the middle cancel out. So I'm left with cosecant squared theta minus 1 equaling cotangent squared theta. Now, I think that's an identity, correct? So let's go back again. Let's erase this. So, yep, this is the one right here. So we prove the identity. So all we have to do right on the bottom is cotangent squared equals what's on the right. So we prove the identity. All right, last question here. All right, this one's a little bit more difficult because it's got a fraction going on. All right, so let's replace everything with sine and cosine. So the top is good. What can I replace secant x with? 1 divided by cosine x, right? Plus, I've got sine x. What can I replace cosecant with? 1 over sine x, right? Has to equal 1. So we're trying to get this left-hand side to equal 1. All right, we could definitely divide this. So think about, how do I divide cosecant x divided by 1 over cosine x? That means I do copy dot flip. So it's basically cosecant x times cosecant x over 1. So when I multiply those two out, I get cosecant squared x. Same concept for this middle part here for sine x over 1 over sine x. So when I go ahead and divide these, right, I'm going to do copy dot flip this times sine x. Sine x times sine x is sine squared x plus equals 1. If you go back to the identity paper, that is definitely an identity. Let's take a look. Yep, here it is. Sine squared plus cosine squared equals 1. So we prove the identity. So 1 is equaling 1.